There you go.
Thank you. Okay, so I'd like to welcome you all to the computer working group. Just in a single sentence, this meeting is about the concept is designing computer networks for analog as well as real Moon and Mars bases. My name is Doug Plata. I'm president of the Space Development Network. The Space Development Network is a free to join network of volunteer space advocates. It is not only a network between individuals, but I like to think of our network as also helping to facilitate network between space advocacy organizations. We ourselves, we are a projects-oriented organization, and at our space advocate level, we seek to forward the cause of space development to the extent that we are able. And so basically, it doesn't matter what level people are at. We're working together and contributing as we can. This is the what we're calling the computer working group in the Space Development Network. We do have these virtual or Zoom teleconferences, organizing people according to their specified interest. And so in this case, we've invited people who have shown an interest in computers and especially networking. And our goals at a minimum is, of course, to have an enjoyable time discussing among fellow space advocates this topic, which I think really has not been received enough discussion. This is what I'm hearing. And also to see if there's enough interest in developing computer networks, especially for the analog setting. And if there is enough interest, then perhaps we can follow up with periodic Zoom meetings and begin to identify priorities, assign tasks, and to seek and make real progress. Probably writing some documents would be an early deliverable. And I probably don't need to mention this, but let me just say that we're very open in terms of who can go ahead and join these Zoom meetings, but we do have to be respectful for other voices. Basically try to not interrupt. By all means, don't dominate the conversation. And if somebody joins and they have a little problem with self-control and they are dominating and disrupting, then they simply probably wouldn't be invited to the next meeting. But that like rarely, or I haven't really seen that happen. And also, it's really easy, including in on this topic, to sort of get sidetracked on tangential topics and spend a lot of time. And we'll try to bring that back onto line and sort of keep focused on what we're working on. So let's go around. There's 6 of us here right now, although I'm thinking in a moment I'm going to be sending out some text inviting people who said that they're going to join us. I'm afraid they may have forgotten the time. So I'll go ahead and send out some text. But in the meanwhile, let's just go around and introduce ourselves, your name, and we need to keep it brief. A name, where you're located, what you do, and like no more than 15 seconds, just a statement about why you might be particularly interested in this topic. So I'll start. My name is Doug Plata, and I am the president and founder of the Space Development Network. I am a physician in Redlands or Southern California, and I'm not I don't have really any expertise, but working towards ultimately space settlement, I do think that initial permanent base does need a computer network system, and so I've largely been the one to pull this together. Chris, do you want to introduce yourself? Chris is in the Space Development Network. He's our vice president for Earth Independence. Chris, are you there? Okay, maybe he was not able to join us, or he's doing something.
Hey, Doug, can you hear me now?
Yes, go ahead.
Technical difficulties. I apologize. My name is Chris Wolf. I'm the director of Earth Independence, as Doug mentioned. I am also a systems integration engineer at SiriusXM. So I'm in the DC area here today to run a little slideshow for you guys.
I appreciate that, Chris. How about Eric? Do you want to go ahead and introduce yourself?
Sure. Glad to be here. So appreciate the invite. I'm based outside Chicago. My day job is in the data center industry. Most of my career, 25 years, has been in enterprise IT, doing different infrastructure things. The My interest is in adapting enterprise IT for commercial space applications. We have a small project that started with the Mars Society out at MDRS with building ad hoc infrastructure-free wireless networks for analog astronauts out there. Uh, so that's me.
Excellent. Scott, you want to introduce yourself?
Sure. I'm Scott Davis. I'm with the Northern California Mars Society. I live in the Bay Area of California. I'm was involved on the team that designed and created the current simulated EVA suits that are used at the Mars Desert Research Station, and along with Judd Reed, who's also on this call. I've also served as the support for the technical support for the MDRS EVA suits, and the chapter is working on a next generation suit that we want to incorporate more technological capabilities into the suits. So I'm mostly interested in this from how the suits communicate and are a part of the entire system for a analog Mars habitat. So it's mostly from that point of view that I'm interested. I appreciate being invited on this.
Sure. Good to have you. Yeah, Judge, how about Judd? Why don't you introduce yourself now?
Hello, I'm Judd Reed. I'm a retired engineering manager out of Silicon Valley and a mostly retired Internet of Things consultant, living in Washington now. My involvement here, I guess, dates back to I developed a system that was run at MDRS, the Mars Desert Research Center, for several years, which I jokingly called HAL, the Habitat Activity Logger. And it is a similar, but that was a decade ago, and so the technology is not that technology is not relevant, or not as relevant today as it would be as what we're going to be doing here.
Okay, thank you, Judge. That's fascinating. How about Ron? Go ahead and introduce yourself.
Hi, my name is Ron Cole. Doug and I go way back in the Space Settlement Technical Committee of the AIAA. I'm retired. I'm very good at that, and I spend most of my free time in the AIAA space community. I'm currently quite intrigued with the concept of producing some version of a cislunar ecosystem model, and the concept of a computing center on the lunar surface is one of the things that intrigued me to this group.
Okay, thank you, Ron. And then finally, Rick, you joined us a little bit late, so you just give us your name, where you're located, what you do, and just very briefly why you might be particularly interested in this topic.
Yeah, my name is Rick Kwan. I'm sort of taking after Ron in that I'm retired and trying to behave that way, or something like that. He and I have both been members of the AIAA Computer Systems Technical Committee. Let's see, so I'm based in Silicon Valley. Had some experience in embedded systems, a lot more experience in multi-user systems, mostly on the software side, but every so often I get into the hardware. And I do a little bit of writing for the technical committee on, you'll see a year in review in the December issue of Aerospace America.
Okay, thank you. In the next 5 minutes, I'm going to send out a text. There were more people who said they planned on coming, so I'm not quite sure whose numbers is which. So if you receive a text from me inviting me to this meeting, just ignore it because you're already part of it. Okay, let's before we get to Chris and his presentation on the main topic, I did ask Eric Christoph to go ahead and just do for us a brief presentation about the Mesh-tastic network.
Sure. Okay. All right. So appreciate that, Doug. So if folks, I'm going to be actually stealing from my own presentation at Mars Society Convention a couple of years ago. And just a couple of pages here to set the stage. Where is it here? Sorry. There's the share button. Here we go. Okay. All right. Can folks see that?
It's coming. Yep.
Yep.
Okay. So just to set the stage, reminder, I think folks here understand Mars Desert Research Station, what it is. We had one of the guys from the Chicago chapter who had been on a couple of crews in the past, and on one of them, he'd had a bit of a scare from heat exhaustion while he was out on EVA. And that his scare, everything ended up fine. They were able to stay in sim, and he made it back to the hab fine, and the crew, their 2 week mission, the rest of it was uneventful, but it was a little bit of a scare, and it got him thinking that, at the just because it's pretend Mars doesn't mean it's entirely, danger free. And any kind of, risk is made worse when you have limited communications. And the analog radios that are out there, they're not ham radios, but that's the best way to think about them. The terrain limits, there are radio shadows, and there's crews they have to plan well in advance. They have to get approval for where they want to go. There's limited range, and all of these things are basically driven by the constraints of the inherent risks that are out there. And so we thought, well, if we can't make all of those things go away, but is there something that we as a chapter could do to try to mitigate some of these things and feel and honestly, actually, it was the NorCal guys that kind of gave us inspired. We wanted to do something where we had a project where we got to get our hands dirty and contribute something out at MDRS. And so this is actually the guy who inspired it, Kent Niebergall. And so the goal of the project is to improve communications. If you get better communications, better situational awareness, then the EVAs are safer. If EVAs are safer, you can do more on those EVAs, and you can do more kinds of EVAs, maybe go further. And then if you've got a nice platform as a result of that, maybe then you can add other kinds of cool, fun features on top of that. So and this is my second to last slide. The key thing to be aware of is the system is it's a mesh network that integrates these 4 different system segments. On the top left, the analog astronauts that are out on EVA. Bottom left, the HAB. These are the folks that are not on EVA but are back, waiting and listening on the radio and hoping that the EVA is going well. You got remote users that can participate in real time in a virtual reality digital twin of MDRS, kind of look over their shoulder, so to speak, while it's going on. And then finally, there's kind of think of it as like a help desk for Mars, so to speak, for this whole system. And so the kind of a system concept view here is if you look at the bottom left, you've got the analog astronauts out on EVA, and Scott, we have a conversation that we're looking forward to having sometime later in the year about your new suits, because right now we have these little T-Echo radios about the size of I don't know, maybe half the size of a cell phone that the analog astronauts put in a pocket and carry out with them on EVA, and it uses the Mesh-tastic protocol stack, and these little radios, they're called T-Echoes. They ping. Here I am. I'm radio number 2, and here I am. I'm radio number 2, and here I am. And it just pings that out. Everybody has a radio on them, and those messages hop kind of breadcrumb style, astronaut to astronaut until they get back to the HAB. And then those telemetry signals get pushed out to a broker That's here in the middle. You see something here, the MQTT broker. It's also referred to as a mosquito broker. That's the nickname for it. And all those messages go out there that says radio number 2 at timestamp X was at GPS location Y. And it builds up that database, and it's constantly logging and tracking. And so it knows where everybody is in real time while they're on EVA. And so you've got the log there. You see the GPS logging. That log then feeds into the digital twin, which is working today. It's based on the Mars VR. And so we've got folks in VR that can be tracking along in real time. We've got real-time logging of locations. You can do text messages over the same infrastructure as well. It's not suitable for voice or video. The underlying technology is very it's fairly long range. It's very low power. It's inexpensive, but it's very low bandwidth. And then the final thing is that we're using Discord as a basic think of it as a middleware layer for voice. So we actually have a listener process that listens on those analog radios that folks use and pipes that into using Discord in the middle. Eventually, we're going to be replacing Discord. That was part of our proof of concept. But it pipes that audio into VR as well, so people can listen. The people in VR know it's the actual radio traffic that's going astronaut to astronaut, and then we can log that as well. So we have logging of where people are going, and we have logging of the audio recording, which opens up new kinds of interesting science and telemetry, planning, debriefing, post EVA, all kinds of things like that. And so this is what we've built. We've been working on this about 3 years. Is it 3 years? Yeah, 3 years. It was first prototyped on James Burke's Crew 261, and it's been getting sort of ad hoc use ever since. We just shipped out a batch of 10 T Echoes for this season. And so this season is when we hope to collect a lot more data and add things. And time permitting, I can get into talking about a lot of the other add-on features that are going to be built into the system if there's interest in that. But that's the basic idea. So these T Echoes form a mesh network, telemetry data logged, and then we build features and integrations on top of that base infrastructure.
Okay, thank you for sharing. And could you, yeah, that's great. We've had a couple of people join us, and I'd like the two of you have joined, Darren and Ryan. If you could just introduce your name, where you are, where you're located, what you do, and also why you might be particularly interested in this topic. Let's just go ahead and start with Ryan.
Hey guys, Ryan Motley. I'm a biologist, so it's okay is sort of my tagline. But I do a lot of electronics and sort of weird consulting. My personal deck, when somebody asks what I do, that I send out, calls me the defornicator. That's a title that I've earned because I just unscrew up other people's stuff. But right now I'm working on some plasma geothermal related stuff and using a plasma-based drilling system. And I've got a small startup doing, oddly enough, mesh-connected drones for firefighting. So actually carrying payloads. But LoRa is one of our end node solutions for keeping the planes from bumping into each other. So that's what I was asking. The mesh-tastic thing is something that I was just introduced to about 3 weeks ago. And I'm like, oh, that's cool. And I didn't poke around with it. And then I quick Google was like, oh yeah, they're both LoRa, just not LoRa WAN. So yeah, got it. But no, it's really cool to just be able to pass like quick text messages and stuff to keep things alive and not bumping into each other. Like, wow, what a concept. And it's cheap now. But yeah, so lots of little projects like that. I've done some wireless remotes for heavy equipment, and just somebody will give me a call and they need a thing and they've got like 80% of it. And I generally fill in that last 20 that makes it not really, really, really expensive. So,
all right.
That's me.
Thanks, Ryan. Appreciate it. Darren, you want to introduce yourself? Darren, can you hear me? Let's see if he's still, yeah, he's still there. But anyhow, well.
Oh, there we go. I got caught up on the permission that it was being recorded. I'm in Loma Linda, California. I'm an electrical engineer. I've got an interest in space. Not so much experience in RF. I have the educational background, but my only exposure to LoRa is I read on or watched on YouTube. Someone's got a 10-cent microprocessor that they're able to get LoRa packages out of, and they're able to run it with that. So I thought that was pretty neat. The most recent project I've done is I'm just designing a parameterized way to make a wide bandwidth antenna. That was kind of fun. I haven't made an antenna before, so that was kind of an interesting thing. I haven't tested or simulated the RF parts of it, but it's just an LPDA antenna. You set the bandwidth, it puts it on a PCB for you. So that's kind of a low price solution to antennas. It strikes me, if you're building something that's actually going to go to the moon, it's a completely different exercise than if you're building something that's going to be an analog. Somebody's going to go to the moon in the next 5 years. So if you want to kind of be serious, it'd be nice to build something that's literally going to be okay on the moon. That would make this much, much, much more interesting than just kind of an analog.
Thank you.
Sure.
Yeah, I agree with that point, and I think we'll get into the discussion. I'm going to turn it over now to Chris Wolf. He'll take the main lead in this presentation. His presentation is about half an hour. After that, we'll have a period of Q&A, and then we'll transition to general discussion, and then hopefully towards the end, maybe try to figure out where we would like to go as a group if there's enough interest. So, Chris, let's hand it on over to you.
All right. This is coming through okay for you guys?
Yes.
All right.
So I'm
Here
not.
we are. No, I gave myself a presenter slide. This is just for the template. Sorry, Doug.
No problem.
Building our own analog-based computer networks. I am presenting today. My name is Chris Wolf, Space Development Network. Currently the Director of Earth Independence. I am also a Systems Integration Engineer for SiriusXM. I have a background in broadcast automation, software QA, and integrating complex chains of products from multiple vendors to get things done. So my focus tends to be the edges of systems and forcing them to talk to each other. And I can tell you that those kinds of integration programs always take longer than you think they will, even when you take that into account. So quick overview on what we're going to cover. I should mention up front that this is before the working group has really sat down and hammered anything out in detail. So this is going to be somewhat of an overview, perhaps even a bit superficial with few specific recommendations, but those are all things we'd like to fill in as we progress. So we'll talk about why we might want an off-the-shelf focus, some details about network layers, sensors and collectors, backends, front ends. The main thing about commercially available components, this space has a tradition where every gram counts, and if you're going to be spending a few $100 million on a thing, spending an extra $100,000 on making every last part perfect is fine, but we're getting away from that. We need to get away from that to make these things sustainable. So wherever we can, we should be looking at what already exists, what can we adapt, that kind of thing, reduce costs. But more than that, these things, products that are being developed and sold for users on Earth, they have much broader user bases than any dedicated space technology is ever going to have. So that means, there's an entire industry dedicated to some of these things. So we get to share the benefits of development and competition, patching, security, all of those things without having to pay for them up front. And then also, when you're using industry standard platforms, you have access to people who know how to use them because they're everywhere. Network layers. This is a little more physical than the rest of this discussion, but essentially we were discussing the use of low energy Bluetooth and Wi-Fi for internal communications, and then perhaps technologies such as WiMAX or cellular for external devices like rovers or astronauts on EVA. Although it sounds like better options exist that I wasn't aware of coming into this, which is excellent. In terms of infrastructure, this primarily within a hab or within actual physical structures, presumably we would just use wired Ethernet. It's cheap, it's high capacity, and it's widely available. Depending on the level of data collection and analysis performed on site, you might just continue with that same Cat6 copper, or for a larger center that's processing a lot of data all at once, you might even get into some higher end 40 or 100 gigabit fiber. Then getting back out of that system, out of the simulated environment, an uplink, either a local ISP or a Starlink satellite link, that's where you would have an edge gateway or firewall for security, remote access, that kind of thing. Obviously, if that's on an actual lunar base, everything up to that uplink could be exactly the same hardware as used in the analog base, and then the uplink might be, or would be, something else, some kind of optical relay. Bandwidth from Earth to other bodies in the solar system is limited. So that is definitely a factor to consider when looking at how do we deal with network communications at an actual base. In terms of sensors and collectors, we're kind of approaching this from the perspective of a lot of the parts, a lot of the systems in a habitat will be smart, intelligent. We'll have, temperature sensors, all kinds of sensors and controls everywhere. It makes sense to take advantage of some existing home automation systems to be able to control things like lights, comms, temperature, any smart devices, but then also tie in industrial sensors, humidity, gas composition, radiation. Those have their own not necessarily compatible protocols and interfaces. And then science instruments and rovers tend to be sort of unique. The communications protocols chosen for those tend to be specific to the instrument and the mission, so it can be hard to is statements about things like that. But aside from the physical endpoints, we also are interested in things like application logs, where you might have an experiment or a device or an instrument that has a data collector running on it that might be scanning for messages of some particular type or quality, exception logs that raise an alert and send a message to someone that then tells them, hey, please pay attention to me, instead of just dumping all of the data raw. Not necessarily every piece of information is useful. So sometimes we want things to listen at the site of data generation and analyze that. We're also interested in user-entered data, config database inventory, and then interaction from touchpads, physical controls. And that could be as granular as light switches, even, to be able to tell which lights are on and off. On the back end of that, especially for an analog base, we're going to be constrained by resources for a lot of things: hardware, software licenses, skilled management. Competent IT people are relatively expensive. So the solutions chosen will depend quite a bit on budget for that. But in the general sense, the sort of three primary bits of interest here: storage, compute, and application services. Storage kind of depends on what exactly we're doing and how much we're saving locally. If we have a rack of computing equipment at the site that can do data analysis and generate reports and dashboards and that sort of thing real time, you might need quite a bit more on-premise storage than you would if you were uploading just about everything to the cloud and analyzing in AWS or something. Compute, generally speaking, should always be virtualized unless you have a very good reason to have dedicated physical hardware. It's just the ability to have hot sparing, failover, to recover from single faults is very powerful, as is the benefits it brings to things like maintenance windows, where you could take a device offline, put a replacement copy up, and maintain the offline copy, applying patches, that sort of thing. And for a lot of applications, it would be better to containerize where possible to minimize overhead. And that's not always possible, but it's great when it works. Then application services, if you have a good foundation of storage and compute that's sort of standards compliant, you can build on that and deploy whatever applications you need, whether it be anything from a simple script server applet that's doing basic analysis for alerting, all the way up to advanced machine learning analysis of everything from patterns in temperature logs to the cycle of oxygen and CO2 balance and gases to how fast astronauts are moving during their EVAs, whatever it may be. So some things to consider. We should generally consider cloud hosting infrastructure to minimize the hardware that's on site because it's expensive. But the balance or the drawback to that is that when you're actually running an experiment or generating a lot of data, you'll have higher running costs than you would if you owned the hardware to begin with. And then also, if your internet access goes down, you're stuck until, you'll have to cache whatever data you have until you can reconnect and upload and get caught up. And again, generally, we should consider off-the-shelf software as much as possible. Elk is powerful and flexible, and there's about 1,000 ways to put together a Linux stack that can power a web application that's very flexible. Changing track a little bit, on the front end side of things, we're considering a single integrated user interface for people, ideally web-based for compatibility, ideally customizable by a user. And I have a bit of an anecdote for that. In my systems integration work, one of the things that we are working on is building out new broadcast studios for SiriusXM in a data center. So these are accessed remotely by people. Normally, you'd have the traditional physical radio studio with the giant console and all the faders and all of that, and everything's physical and tactile and all of that. But that's not scalable, and when things break, it doesn't fail over very well either. So we use a lot of VMs, we use a lot of software interfaces, and one of those is the actual console itself. Instead of a board with physical faders and all of that, you get a touchscreen. And the modules that are displayed on that touchscreen are configurable. So I can have one user come in, sit down, and they can load an environment that pulls up another studio in Los Angeles, for instance, and all of their audio routes are brought to them. Their whole environment is loaded up, everything's ready to go. And 2 hours later, somebody else comes in using the very same studio, or even remoting into the very same studio from home. Maybe they're running a sporting event. So they've got a game, they've got a completely different arrangement of faders brought up, different audio sources brought in. Their whole environment changes. They have access to everything the other user did, but they can also save their profiles and load things up like that. So a similar approach applies to things like a workstation that you might share with other people. Being able to sit down and load up a customized environment that brings up all of the information that you might need, any controls you need access to, and be able to hand that off to somebody else quickly without, scrambling to change your seat back position, as it were, is very useful. What we're imagining is that a lot of these interfaces are touchscreens, basically iPads or similar. And so the processing power on those is not amazing. Ideally, you would want to do a lot of your processing server side and just return data for those devices to display to users. In terms of the user experience, we would like to see voice control for basic functions. So I'd be able to ask for the lights to be turned on, ask for a heater to be turned off, that sort of thing. Touch panels in areas, and maybe you have a panel by a wall where you can pull up environmental information. But then if you dig in further into menus, you could get all the way into everything else that's in this system, including, knowledge-based articles, help guides, pull up a Discord channel and talk to people with voice, that sort of thing. And then where you have more complex tasks where you really want a keyboard to be able to write things, you use a PC or a laptop for those more complex tasks. So again, speaking generally, a unified interface to these multiple backend repositories. I'm realizing I may have made some editing mistakes in my backend discussion. Essentially, we're collecting data, a lot of different types of data with a lot of different uses. So you've got everything from activity logs from applications, which nobody's really interested in unless something breaks, but you could certainly monitor and raise an alarm for unusual activity levels, all the way up to really important data that you don't want to lose because it's scientifically meaningful, as well as things that are manually entered rather than automatically generated. So the types of databases that you might store this information in differ. Maybe you've got one for log files that's searched and indexed with Elastic. Maybe you've got one that's a configuration management database like ServiceNow, something that can raise alerts, run monitoring and reporting. Maybe you've got an inventory system. To be able to provide data from all of those systems in one place to a user generally means you need some custom development. Somebody has to write a front end and interface to collect data from all of these endpoints. And you can start with an off-the-shelf tool like Kibana, or within the broadcast automation world, there are vendors like Evertz. They have a product called Magnum, which has these customizable view panels where you can arrange a whole report or status page that can show you things like audio levels at different points along a stream, which sources are routed where, that sort of thing. Those kinds of configurable UIs are powerful for when you have workflows that need to be repeated, whether it's going through and logging data, maybe it's stepping through a greenhouse and recording things like plant growth, or I don't know, it could be anything. Generally, rather than writing something entirely from scratch, you would want to pick an approach that has at least some of the functionality you need and is common enough that you can find people who are capable of adding modifications or customization on top of that. So that's where the sort of traditional LAMP stack goes, although I prefer Postgres personally, but unless it's I mean, I use Microsoft SQL during the day, which is fine, I guess, but it's expensive. Anyway, that kind of devolved into a bit of rambling, but as I mentioned, this is sort of a first look, first impressions kind of approach to what we think we'd like to see. And I'm hoping we can fill in an awful lot more detail on that with everyone here that's interested in it.
Okay, I take it you're done, Chris?
Yep.
Okay, excellent. Let me just add a couple of things for myself. In some of our discussion up to this point, and again, as Chris says, what we're describing here is all very, tentative because this group hasn't met. But we want to throw some ideas out there. One thing is user interface. I did mock up. Let me see if I can find it in photos. Okay, do you guys, let's see. Okay, you guys see this?
Yes.
Yes.
Okay. So this is something I got from somebody has done, just for the fun of it, developed a website that has these Star Trek-like menus. And my thought was that we could possibly, if the group feels that's a good idea, is to go ahead and develop our own, perhaps Star Trek themed menu system. And that would be part of a sub project that we could do as part of this. So that, for example, if you were to click on map, it shows a map of the facilities. Yes, exactly, Ryan. LCARS, that's the Star Trek system. You click on map, and on there, the red dots are where the crew are located. The blue dots are where the cameras are. So you just click on the blue, and now the camera's coming through. So it's basically the fundamental idea is just absolutely network everything. Everything that's electronic or electrical is connected to the system, not only within the base, but connecting outside to power systems like solar drapes or to robots or crew vehicles, but also back to back to Earth, back to the internet, back to mission control, stuff like this. I did want to let you know that the Space Development Network is working with an Israeli fellow who wants to go ahead and start a company to develop a new analog base that would be in the shape of full scale starship, landed and then tilted over, and then 3 floors throughout using all the propellant tanks. So we call that Star Hab. And so for ourselves, we're thinking about how the system could be implemented within that context. I have come up with, again, for the fun of it, a name for the system, tentative, of course, and that would be JCN, which is 1 letter more than IBM, if you get the thing, and that it could be called JSON. So when you communicate to the system, you say, Jason, could you turn on the lights or give me the latest humidity records or whatever? And we could have fun sort of communicating with that. I will mention that in our discussion, we have gotten into related topics, which I don't think would be the main focus of our working group, but is something that we might want to spin off either, a subgroup, sub-team, if they want to work on that. Things such as the electrical system, would we go 48 direct volts direct current, for example. This seems to be what people are talking about. Also, conduits and how, blueprint and how we go ahead and lay out this computer network to try to sort of limit the amount of cabling, and also really a side project, but something that I'm guessing some of you might be interested in. That is, when you're dealing with Mars with a 14-minute time delay, if you have people on Mars that are wanting to access parts of the internet, like they want to watch a YouTube video, how do you get all of that data from the Earth to Mars, both historic data like the internet as it is now, as well as new content that's being produced when you have limited pipelines. And I think that's it for things that I wanted to mention. At this point, let's open it up for question and answers. And then Chris and myself, if we could sort of handle these questions. Do any of you guys go ahead and unmute yourself and feel free to ask any questions or make any comments at this point?
Okay, can I ask a question?
Go for it.
What is the intention of this group of what we're trying to accomplish here? In that, are we trying to create something specifically for the Mars Desert Research Station, for FMARS, for this spaceship analog site? Or are we trying to create a general user interface for computer system in a Mars or Moon analog hab? Because there are quite a few different ones that have been established and tested on. NASA has several. We've got High Seas. There's one being developed in Mongolia right now. I believe China has one.
You're
Russia
talking
has
about
theirs.
analog bases. You're not talking about computer network systems.
Exactly. I'm talking about, are we designing this for general analog bases? Are we looking at a very few specific targeted cases?
Chris, did you want to address that?
I think we want to make this generalizable. So where we're targeting the sort of sideways Starship hab design initially, if we can come up with something that could be adapted to other environments, that would be ideal. Like basically, if we can carry through any of this work from an analog base to an actual lunar base, that would be ideal.
Okay.
Did that answer the question?
Yes. I just want to mention, if we were wanting to make it more generalized, it might be worth pursuing partnerships or relationships with some of the various groups that administer different analog sites. And different ones might have different needs and concerns.
Yeah. I would, if I could weigh in on this, and by the way, Chris, really appreciated the presentation. I thought that was a great setup. So I thought that was awesome. I would say I would expand on to Scott's question a little bit in terms of not just in terms of, okay, like where this could be applied. It could be applied in multiple analogs and ultimately be transferable into an actual base. But what's the nature of the output that we want to do? Like basically, how do we as a group want to move the needle? Is it through sort of demonstrating a concept or a set of concepts? Is it by creating novel intellectual property? Is it to or is it just for fun? All of which are right answers, but it's really, really important to be clear what the goal is. Like, for example, if the goal, or if one of the goals was to create a something that would be saleable, Paramount would probably have something to say about the use of LCARs. So we would want, so like those are like the annoying nits that we'd want to be clear about, to which could shape how the choices we make on things large and small.
Let me just start with response, and I'd just like to point out Ryan has been making good use of the chat, and feel free to go ahead and use that to give your own answers to people that we can read in the chat. My guess is probably what this group would do is it would first start with conceptually designing the computer network and recognizing that there could be different levels of it in terms of like analog based, but maybe there's a simple application at let's say MDRS into demonstration of a full system, and then ultimately off Earth. And so I think by producing documents describing that, I think that might be the first output that our group would. The second thing is, my guess is that we would want to demonstrate some, even if it's not the full system, at least a significant improved system. My feeling is probably MDRS is the first place that would be done, just because we have a lot of connections, and I think there's a lot of support for that, and I think it can be done on an advocate level. But I think ultimately to do the full system, we would either need more people, professional people joining us, or perhaps it would be that we're communicating this vision, maybe implementing MDRS and getting some publicity about it, and hopefully influencing the people who really have the funding and the capability to do it for real, including off Earth. So at some point, we may, at our space advocate level, we may have achieved our goal by transferring this concept to people who can implement it, off Earth. Yeah, Chris or anybody else wanted to add to that?
I've got.
I'm going to.
Oh, go ahead.
Go ahead. Okay. Don't know who's. You go ahead first.
Okay, so if you're actually going to build it in outer space, you kind of have three levels of importance. One level is things that kill people, and you're going to spend 70 or 80% of your effort on that, and it's going to look essentially nothing like anything you've talked about. The next level is where people will get fired, and that's, I think, where most of the effort is. The discussion is at things that would get people fired if it stopped working.
Right.
And then there's personal computing that nobody cares, right? You have your own computer, you do whatever it is you do, nobody cares. And if you're going to build something that goes to outer space, almost all the concern is going to be on, does this work? Will the systems that need to be working to keep people alive work? Now, perhaps that's done by SpaceX and it's in the body of the HAB. But if you're building something that's life critical, it's like a completely different set of logic than what we're discussing. You build the least amount of stuff you can possibly do. There's no layers of this. There's no, everything is redundant. It's like you're building nothing. You're spending an enormous amount of effort to build nothing. And it's because you think about every single aspect of it so very carefully. Now, I'm not trying to hack on what you're doing. You're building a different kind of system. But if you want to go to space, the thing that they're missing is the thing that's going to keep everybody alive.
Right.
So
generally, I would say that, take, for instance, a gas composition analysis instrument. That's feeding data into, environmental control and life support systems. The system we're talking about would skim that data.
Yes,
it wouldn't
correct.
necessarily try to control, oxygen valves or CO2 scrubbers as a result of that. It would be logging that data and providing it for analysis.
So like I want to kind of extend Darren's comments on this a little bit, and I would say that the sort of challenges that Darren talks about, and I'm going to expand on it in a second, don't obviate any of what we're talking about here. It all comes back to, what are we trying to achieve? Because there's a lot of white space, and not all of it. We don't have to go after all of it, and there's still a lot of interesting things that could be done and ways to contribute. But like, I'll give you an example here. From my understanding, the most commonly used piece of compute hardware that's used on satellites and space probes and things like that. It's a particular, I don't remember the model number, but it's from BAE.
Rad 750.
Yes, and it runs at like 150 megahertz or something like that. I don't remember and it's been around forever. and it's slow, and like any one of us, like it coming from, I'm using a fairly respectable gaming grade laptop for this call. And, when you're coming from that mindset, the things that work, need to work for space, like to actually work, the constraints, to Darren's point, can really end up swamping and kind of taking hold of what you work on, especially for a little, or kind of a group like this is trying to put together. But what that still leaves open is if the interest is more, because like I agree strongly with COTS, and I also bring one of the things that Darren talked about is 80% ends up being focused on the life critical aspects of it. Well, if an astronaut dies, if a NASA astronaut dies, it's a national tragedy, right? If a worker on an oil rig dies today, it's an insurance payout. At some point in time, that difference in psychology is going to be evident in commercial space activities. And that psychology flows down to all the kinds of other decisions that is going to be made, which means that, yes, there will be COTS or things that are much more like COTS than they are bespoke systems integration. So one potential area might be looking at like using the COTS type technologies that would be available to us to demonstrate concepts, to demonstrate operating models. And to, in the first version, it doesn't, or of course, the first version wouldn't, we're not going to try to go out of the gate with a TRL level 9 system. But so there's lots that we can do to prove systems and build, to show operating concepts without having to worry about that 80%, if that's the choice. Does that make sense?
I would argue that the 80% discussion is a very important one in the analog space, not just in the space. It's a different 80%, but my experience at MDRS, there were not quite as urgent life support issues that are very critical, like does the toilet flush? Do we have water and do we have power? That are difficult to maintain because the crews are not experts. And I think that tailoring a solution to analog sites has a big enough set of challenges that it'll keep us more than busy. If we take it seriously, that we want something that meets the needs of a MDRS-like site. And I'm basing that on a, let's face it, mixed experience where I developed a system that was used for several years, and it eventually died of bus factor.
Of what?
Died of what?
Of the bus
Bus
factor.
factor.
Oh,
The number of
Number
engineers
of people
hit by a bus, yeah.
Yeah.
I being one of those.
That's a
Okay.
problem in my industry too. Very, very few people know how some of these things work.
but
And maintaining a system that is too custom, or is just too that you don't share the vision on, will kill the system. If the folks at MDRS aren't as enthusiastic about our priorities,
yeah,
then we've done a great exercise, but it doesn't really doesn't move the needle in terms of changing the way analog space is done.
So it's almost like, although they're not the primary customer, they're like an early adopter customer that you need to kind of talk to them or understand their needs a bit.
I think we should.
I guess I'm stretching it a bit here, but
I'm not sure that MDRS is the right analog, but I think we do need to pick one or two analog sites that we want to build the first system for.
yeah.
We need a place to test stuff because we can't exactly fly me to the moon.
Yeah.
Just any old weekend.
Well, and 100%. Yeah. And I could say that. So the little project that I talked about earlier. So, again, that started because a bunch of, a few of us in the Chicago chapter was the middle of the COVID, and we were sick of just listening to webinars like everybody else. And we wanted to find some way to roll our sleeves up. And this guy Kent had an idea, and we were really inspired by the stuff that Judd and Scott and the folks in their chapter do. So we wanted to do something kind of similar. But since then, it's taken on a life of its own. And like our view of MDRS is that, I mean, it's like, and FMARS as well, although the things that make it more interesting from a research perspective make it harder logistically. But they are great sandboxes, right? And the organization is very supportive of folks trying things out there. But then if folks have been following like what folks are working on the world's biggest analog and the AAC, there is a community that's developing there. So like the comment on partnerships, I don't know if we need 30 partnerships. Maybe we just need one with like the WBA and the AAC people, and then sort of use them as a proxy to other analogs since they're already sort of building that. But I agree. I think that we pick a scenario and develop around that, and because that lets us start to build like concept of operations and narratives, user stories, all of those kinds of things that would drive the requirements that would then in turn drive design, so on and so forth.
All the
Um,
program
Yep.
management things.
Can I
Yeah.
make a suggestion that don't know if Judd, if you still have your HAL code at a point that you could present it in any way. I mean, I'm not suggesting today, but it might be worth looking at what Judd had created for the MDRS. And this is, some years ago, and the technology is a bit outdated, but the workflow, what its capability was, what it presented, what was useful to the crews and to the management at the MDRS. There might be a number of things that you guys haven't really thought of in terms of your user interface that might be useful. I mean, being able to plot out EVA trips, being able to have a database of information pertinent to the crews and the crew engineers for working on things within within the habitat, and being able to log their daily logs every evening and submitting them. There are a number of user interface things that are very important for the MDRS, and I would imagine would be important to other analog simulations. Some may value different things over others, but there's probably a lot of commonality.
Yeah, and to put the habitat activity logger in, well, put everybody on sort of the same footing with it. It was a LAMP stack that was hosted at MDRS with a clone that did a nightly backup to, all the new records went to the clone, and it started out for engineering issues, monitoring fuel tank levels and water tank levels and so on. Quickly changed purposes to becoming the report making system because that was the need due to bad bandwidth, due to a communication challenge between the HAB, which at that time, this is back when the network to MDRS was pretty bad, was HughesNet. And I would say that I had a vision for the activity logger that was never really realized, but instead developed a system that had other features because that's what the site needed. It had its own map system and route planning. And it had, and I was working at Google at the time, making maps for Google at the time, so that was part of why it took that direction. But it never fully, it never reached the level of automation that I think it could have. And what it wound up happening was that I simply was too big a system for me to maintain. And everyone who had, every time we got new functionality, it was an independent and not compatible system, and eventually HAL sort of got crowded out. And I don't mean technically, I mean in mind space, in enthusiasm in the organization. I think that's the key to making this thing successful, is that whoever's running the habitat, or whichever analog station we're headed for, they have to enthusiastically want this thing, or we're solving a problem that doesn't exist.
Yeah, you guys, let me just say that I would like for us to make an actual difference in when it comes to space development. In other words, if it takes us a while to go ahead and develop something that's sort of specific, let's say for MDRS, but at the same time, SpaceX and NASA are partnering together, and they are landing cargo on the moon or Mars, and they're landing crew. And if we are not relevant to them, then they've got to develop their own systems, and we may end up having no particular input on what happens off Earth. And I'm concerned about that. I'm hoping that what we do, to me, sort of a major goal of this project would be to communicate to the decision makers who are going to make the real difference off Earth, whether that is probably in this case SpaceX and NASA. And so to be able to have something that illustrates the concept is something that I think might be our goal. And what I'd say is that I feel as though, as it stands right now, we have a pretty good idea about the vehicles that will be going to the moon and Mars. That's being taken care of. I think NASA is itself an organization that it feels as though it can handle. It has systems for doing EVAs in the sense that, the whole mission control and the International Space Station, they are really on top of those sorts of things. But my feeling is that what's lacking right now in the big picture is what habitat are we going to have on the moon and Mars? What agriculture systems are we going to have? What power systems has that been decided? And so there's a lot of an unfilled niche of basically the habitat, and what goes on, especially inside the habitat, is something that I feel as though is not being addressed by NASA adequately. And perhaps we can illustrate some concepts that could get their attention and might impact the direction that they take it.
Doug, I think it's really interesting that you bring that up. If folks don't follow him, this isn't a guy who focuses on technology. He focuses on life support, particularly like bioregenerative life support. He's a researcher in Purdue, Dr. Marshall Porterfield. And if you follow him, the only social media platform I use these days anymore is LinkedIn. But even there, he will comment colorfully on the ways in which China is, like, their moon plans are ahead of what NASA's contemplating for Artemis. Basically saying that for the kinds of questions that you raised there, Doug, that he claims anyway, and there are some people that agree, that China is further along on thinking about the things that are important to really stay and do work there, as opposed to visit occasionally and conduct occasional experiments. Thanks, Darren. And so if we want to think about a way to get NASA's attention, and ultimately, that of the commercial companies that are going to be executing on these things, one approach might be to first study the gaps between what's identifiable and learnable about the Chinese program, and work on addressing those gaps. Is there a way that, like, okay, NASA, you're not thinking about X, China is, and we're not doing all of X, but we're going to come back, and we've got some ideas and a demonstration and a bunch of white papers on that'll get you halfway to X. and that, do the thing that nobody's doing.
Is this fella Marshall Porterfield? Is he specifically addressing bioregenerative life support?
That's his area of research. Yeah. I don't want to overstate my relation to him. I've been on one video call with him, and then I follow him. But the reason I bring it up is because there are people making noise that China is taking it more serious what's required to stay. And that may be an opening to make a difference.
So I guess just on that point, I guess I'm suggesting we might be careful about what we start pursuing. Bioregenerative life support, as I believe, and Chris, I think you'd be particularly helpful.
Yeah, my point, by the way, wasn't on life support or anything. It's more the general observation of the gap, not just on life support, on everything else.
Yeah, so I would say I'm going to go back to bioregenerative life support because it could be, this is arguable, but it could be that China is pursuing something that is maybe not the simplest solution. It's maybe more complex, and I guess what I'm saying is that we need to make sure that we are filling a gap that's not necessarily a gap between the United States and China, but a gap in establishing a permanent base on the moon and Mars. What is China? What is NASA not doing, regardless of what China is doing?
Yeah, I would tend to actually ignore them because I think they're ignoring us. They really don't care what the U.S. is doing, right? They just what I think. Okay, so I was just there. I did not get into any aerospace facilities. Well, I went to one aerospace enthusiast museum. That's as far as I got, but I didn't get any special information. But my general observation of what I've been trying to figure out of what they're doing is that the way they differ from us, I think, is that if they decide that the thing is important, then there probably will be a budget for it, but they'll probably be more forgiving for things getting screwed up. They will continue to put the money in there. They will make sure the thing actually works. They won't cut it off after 1 year or something like that. They will maintain the course, and they probably got about 5 times more engineers than we do, just because of the size of the population.
Yeah, right. Yeah.
One thing that I'm thinking of as everybody's talking is we seem to be focused on what kind of vehicle or what kind of hab or sort of backing the bus up. My brain's doing a thing. So I'm working on this wireless remote for a company called Barbco. They make boring machines. They make a line of like 16 to 20 different machines, depending on what year it is and how many people really want that one version that they made 10 years ago. And so they asked me to design a wireless remote for one of their boring machines. And then they added a feature about a month later. And I'm like, well, what else are they going to throw at me? And so I looked at their most complicated machine and counted inputs, added 20%, and said, I'm going to build a wireless remote that handles this many channels. And I have analog and digital signals, and it will talk CAN bus, RS-232 serial. It will talk Modbus, I2C. Shut up. Sorry, I have 120 pounds of Doberman that really, really, really wants the nothing that is on my counter that he can eat because it's all onions and hot peppers. And gochujang. That's Nelson.
Oh, that's Nelson. Okay, no, Max is gone.
Yeah,
never mind.
Yeah,
that's a side story.
This is Nelson. Anyhow, but the point is, like, I have no idea what kind of machine they're going to be running next year. I have no idea what kind of machine they're going to bolt this to 5 years after I quit working with them. At least in this capacity. I mean, they're really cool guys. I don't want to lose them. But the point is, it's got all these capabilities, and so I have the code set up in such a way to where, we need another stick to run this feature on the machine. Cool. Is it an analog or digital feature? Cool. Drop this piece of code in. What kind of stick is it? Analog or digital flippy flip? Oh, cool. Drop this piece of code in. What are you going to call it? No, stick 12, flippy valve. Cool. Done. And then it talks. It took you 45 seconds to add the code, a minute to compile and upload, and now you're on this network. I think what we would be better off doing is building a really fast, efficient database or database of databases that would store where the hell John is, where the heck rover number 6 is, when it was, and what its last heading was. We basically draft up essentially like D&D character sheets for everything that we want in this database, and it just gets updated as live as we want it to, or not. And then the thing that interfaces with it can either be the device itself, like I will murder you, stop. It's either the device itself that we build the smarts into, or we just design a network interface device that talks all these protocols and ours. Done. And it talks to the database remotely. We can figure out whether we want to use Wi-Fi or Ethernet or whatever, depending on the particular application. But that's it. Like I'm radio agnostic, network agnostic, and this thing actually goes and has a RS-485 tether that I plug in, and it immediately switches over. Oh, I'm on tether mode. Cool. I'm going to charge from that, and I'm going to send data over it, and I'm going to turn off my Wi-Fi. Cool. And then you unplug the tether, and it's immediately back to Wi-Fi, and it's on internal power. These aren't super hard things to design in, but it's like if we design for the case rather than the thing, then we can handle all of the things.
Mm-hmm. Strikes me that there's a need that this group is probably well situated to solve. That is one level above the interfaces where we've been talking, and by analogy, I'm going to refer in medicine we've got DICOM, where all the different vendors have one protocol that they all use, and everybody's workstation looks at everybody's data. In astronomy, there's ASCOM, where all the vendors can you can plug and play devices from different vendors. That might be where we need to focus, is on developing the standard and the communications, not at the level that we've been talking, but at one level higher, the application level.
Hey, Chris.
Yep.
So we are down to our last 10 minutes. I'm wondering if maybe you might be able to take the lead in helping us think about our next immediate step.
Oh boy. I heard 5 or 6 different ways we could take this in our freeform discussion here. But it sounds like what we need to do is start down that project management path, identify what problems we want to solve, come up with a list, brainstorm that, and then out of that, pick what we think we can actually make a difference with, something where we can show some meaningful progress and start picking away at that. And it's good to have the sort of end-to-end 10,000-foot view discussions, and also talk about future uses and future applications, but we also want something fairly concrete to start with. I'm not entirely sure I can answer that just off the cuff here, to be honest.
If I may, I could just to maybe get help get the ball rolling on an idea, and then if the right answer is to throw darts at it, please do. But just for to put a line in the sand, I guess. One thing that a place to start would be to pick a scenario that we think that would encompass, doesn't necessarily have to cover all of the goals maybe, but like a scenario that would cover the interesting things to the group. And then within that scenario, which parts of that scenario do we want to try to solve? And then we put together a set of, here's the protocol line of work, and here's the knowledge management line of work, et cetera, all within that scenario. One we haven't talked about, one that I think, Rick, you mentioned, think it was Rick that mentioned it, or it might have been Ron. But actually, I think it was you, Ron, who mentioned it. Um, cislunar. Um, and
As Ron.
imagine if we took something that this hasn't been talked about in a while, but remember ULA's cislunar 1000 concept about 10 years ago? I actually used that for in graduate school as sort of a framework that I wrote all of my papers around because there was enough detail there that you could kind of hang off of it. But let's say, for example, we just pick, it doesn't even have to be the right scenario necessarily. It needs to be a scenario that we can use to organize around. Okay, what I did is I said, okay, let's just assume cislunar 1000 comes to pass. Okay, it's happening. What does that need? What does that imply in terms of all of the systems, the IT systems? ULA did a great job talking about how their Vulcan rocket would be, important to making cislunar 1000 happen, but they didn't talk about IT at all, right? So like it doesn't. I'm not saying that that's necessarily the scenario to follow, but can we come up with a scenario? Maybe it's ESA's Moon Village as a scenario. Maybe it's Artemis Gateway. Whatever it is, we pick a scenario, and then okay, what are the gaps? And that are specific within the HAB computer environment, and go from there.
Let me just comment too that I like where you're headed. I would propose that if we're going to make a real difference, we need to identify the most probable scenario. I would say at this moment, just as an example, probably Gateway. I don't think that's a probable scenario. In other words, I think that we need to look to the future and say what is probably going to happen, because if it probably is not going to happen, then if we work towards that, we're not going to be relevant. And my feeling is the Starship fleet is probably the dominating factor that's going to determine what's actually going to happen in the future. And so maybe we could develop a scenario based on that. And definitely Lunar 1000. I don't think that was really.
No, I could get behind SpaceX.
And the thing that SpaceX is going to not do, right? So SpaceX has got a whole lot of things they're going to do very well, but they're not going to do space mining, or they're not going to do, making semiconductors. So if you could figure out how to glue all the people who are doing that stuff into SpaceX, that might be a real value add.
So one other note from a call that I was on earlier in the week, it's the Expeditionary Operations Group. This fellow from Brick and Mortar Ventures set it up, and some folks from Texas A&M and other places, and me suddenly because plasma drilling. But we're talking about operating in austere environments, and the military is looking at the moon as a good analog for what they do. Operating in the middle of frickin' nowhere with crap for resources, and you've got to figure stuff out on the fly really fast. And this team awareness kit is a civilian Android version of what the military uses for essentially asset tracking. When I put in the text chat radioactive zombie outbreak, that's actually really good analog for anything where you can't move freely, because there's a thing that wants to kill you all around you, like vacuum or actual zombies, or hordes of people who are hungry and starving and want to take your food, or hostile enemies. It's just danger, and when you're inside your base, there's less of it. So like, it doesn't really matter what station we go with or plan. Basically, are we on the surface or are we in orbit? What kind of activities are we doing outside, maybe, and in what kind of vehicle? But I don't think it's important whether it's Boeing Starliner or Dragon 3 or 4 or Starship, or maybe they bring back the 70s lunar rover. Cool. If we build the system right, all I need to know is how many sensors, what type, and what they speak, and we can connect them to the network, and in a matter of minutes have a head-up display or whatever kind of LCARS kind of thing that you want, that's built for it if it's modular and adjustable enough. Because I'll tell you right now, I'm going to be modifying the ever loving hell out of my dashboard in my rover because I'm going to have pink fuzzy dice and a little animated something in the corner. And I'll have the sensors that I care about on there because I care about gear wear in the transmission, even though Sally cares more about the inflation of the tires. Damn it. You know, that kind of crap. It's going to happen all the time. And so if we build this thing as open source and modifiable as possible, but also make it bulletproof, I think that's kind of our prime directive here, as opposed to really caring what, you know, brand of engine is in our rover. As long as it's an engine that talks CAN bus, cool, we'll plug it in. And then that way we can shop it to whoever the hell wants it and charge them through the nose for consulting costs.
Chris?
So this is something I find compelling. The having an interface that's flexible enough to add new processes, new products, new features, perhaps even discoverable or software defined if you like some industry keywords. As I mentioned, we kind of want to approach this from the user interface end of it and work backwards so that we're less constrained to some particular database or what have you. And I think that's actually something that could be useful if we can provide to people an interface that, like I said, can access various things. If you have a wiki page, you can get a text search box that will pull up how-to guides, troubleshooting. You can connect to an inventory system or a change management system and see, you know, what's configured, what's available, what's on my network, what's in the pantry. Those are all useful things. I don't, go ahead.
No, go ahead.
I was just going to say, I don't know that there is necessarily anything like that right now. Pretty much any organization that's big enough to need a multi-database interface like that just does it in-house because they can afford to put, you know, a team of 2 to 4 guys on it, and it's no longer an issue. But
that's exactly what we're running into now. And revision 2 of this wireless remote is going to allow for like remote diagnostics and stuff. And that's where we get to that complexity of like multiple databases and sensor. So that flexibility, I'm having to design that now. We're using Rick is going to chuckle, a PIC32MZ processor.
No, I'm not going to. No, go ahead.
Anyhow, but we're going to be running a Linux implementation on that so that we can have a touchscreen interface and a couple other odds and ends. Yeah. And then the PIC32MZ DA is the graphics processor. But anyhow, I digress. But yeah, that whole thing is like, you're absolutely right. I am the in-house for Barbco. They're a $15 million company. It's not like they're rolling in the dough, but all of the solutions that are out there are very selective and stupid expensive.
Yes.
And I can come along and build some device for like $600 that replaces a $7,000 pass-through cost that they were charging their customers previously.
Yeah. I mean, even relatively large companies, like my employer's their market cap's like $38 billion. And we still have, you know, people whose job it is to write scripts.
Could I have a rounding error, please?
Yes, exactly. So that's actually something that has at least some potential for commercial success, even though that isn't really the point. It's that there are a lot of companies in that space that do middleware, but if we could come up with something that smaller groups could actually use like that and adapt to their own databases, their own sort of services, I think that would be
I'm wondering if there's a semantic difference between middleware and framework, or maybe it doesn't matter.
I mean, those are different things, right? But
yeah, I'm thinking of, I was thinking about framework probably because we were talking about user interfaces and building other things on top of it.
Yeah, that's
how are we doing in terms of concluding the session and having an idea for our next meeting? In other words, do we feel like we have a general idea of where we're going?
More or less. I think there's still room for another brainstorming sort of roundtable discussion on options and possibilities, but unless anyone has strong opinions otherwise, it kind of sounds to me like um, that scenario I just laid out, coming up with some kind of tool that can connect to multiple databases or data sets and present that information to a user in a customizable way is the focus.
I've been writing some information in the chat, which is perhaps too low level, but this is kind of the baseline of where NASA and JPL are headed for. I would guess the next 20 years. So we were talking about the BAE systems RAD 750 earlier. That's been the workhorse for the last 20, more than 20 years at this point. That was not by design. It's because, well, some other contract fell over, and the replacement was supposed to be an ARM V8 system, which did not happen. And so in the last 3 years, NASA, well, let's see, yeah, I guess it was less than 3 years ago, NASA gave the management of the project over to JPL. JPL picked a new vendor for this. The vendor is Microchip. That is probably going to be the thing that flies. I have a funny feeling they're going to use that particular processor in Dragonfly and a whole bunch of other things. I mean, BAE systems were not like this, but that probably will be the replacement for the RAD 750. They have something else that they call, I think, the RAD, not RAD 6000. They've got some other design based on another PowerPC, much, much faster than the RAD 750 is. And so they've been building that out for a while, and they've got some commercial deployments. But for future NASA missions, I believe the direction is going to be as they're going to do the PIC 64, which is the thing that I posted in the chat. So if you wanted to use something as a foundation, that's open. Well, okay. So you don't need to necessarily use that particular RISC-V chip, but if you had something that was built on top of RISC-V and had a Linux foundation on top of it, you're getting pretty close to what NASA is probably going to do on its future missions.
Darren, I feel like maybe you have something specific that you'd like to share.
So if you're going to interface with a third party company, they're sending out trucks or something, the interface is probably RF. So the idea of three kind of layers of thing. One layer takes your RF and turns it into a network package or whatever. One layer takes that network package or Modbus package or whatever packages you've got locally and puts that into a database or databases or whatever. And then you have a layer that does your fancy UI that takes the database and turns it into something pretty that you're looking at. And it seems to me that if you kind of want to, go big, you build everything like you're going to take it to the moon, because 5 years from now, somebody's going to need to take something to the moon and nobody's ready. So you might as well build something that can go to the moon. It's not that hard. I mean, it is that hard. There's real things you need to do. It's a real discipline, but there are off-the-shelf ways that you can do it close to what NASA is going to end up doing it. But if you have those three layers where the RF is a clear thing, it has a clear set of requirements on what it needs to do. However many databases you're going to stuff your data in is a clear thing. It has a clear set of heuristics on how you do it. And then whatever UI you create from that data is a clear thing. It has a clear heuristics of what you do it. But the RF is like an important system that you're going to run important data through. Some customers don't want you touching their data. They want it to put into their database. And so you have the ability to package it into a database you don't maintain, that you're never going to deal with. Mm-hmm. And then some uses, they want you to do the UI and you do the fancy thing like you guys are talking about. But you have the ability to do kind of multiple things at multiple levels of life criticality or data criticality or whatever.
I tell you what, we are beyond 90 minutes right now. Let me suggest, Chris, do you think that you could create maybe a little statement or something that maybe outlines your idea of where we might be heading? in preparation for our next meeting, and then in our next meeting, I'd like to get an idea of when you would you guys like to meet next.
Yeah, I'll go back through the recording for this in my notes and try and summarize, see where we're at.
Well, not just summarize, but propose an idea for what we might do and where we might head, and as a proposal to this group to see if they agree with it, or if they want to modify it next time. But then hopefully next time we'll begin to have more consensus and start laying out what we need to do.
Sure. And I should mention, I love feedback, especially people telling me I'm wrong before I make a fool of myself. So by all means, say so.
Yeah.
If I could just jump in here, Chris, it's our first time chatting, but if I can help, please don't be bashful reaching out. I'd love to help.
Will do. Thank you.
Yeah, can we get a like an email list or something, just like a quick one where everybody's visible if we want to? Like, I'm cool being contacted or get, whatever. It would be nice to hash a little bit.
Yeah, I can go ahead and come up with that list and just send an email out to everybody so we're all talking to each other.
Awesome.
That would work.
I mean, we're definitely not nerds, and we certainly won't ever want to like crack a beer and talk moon crap,
Never.
Right.
Ever. Yeah. You horrible people, get away from me.
I don't.
Hey, Doug.
Yeah.
This is Ron. So I wrote down two lists while I was listening to all this discussion, and I will allege that they are incomplete because I'm not that smart. But one of them has to do with the actual space environment. We've talked about doing stuff on Earth and doing stuff on the moon or Mars. The moon and Mars are different. Gravity, radiation, temperature, power, weight, and volume, those are traditional space factors that affect anything. But, if you're going to be on the moon for many months, you're going to have to endure some extended periods of brutally cold periods if you have sensors outdoors or if you have computing systems outdoors. So it seems to me that capturing sort of the environmental challenges or risks of a lunar or Martian, and I'll assume those two are reasonably similar, although I'm sure there are some differences, but those surely would have some impact on anything that we thought we could migrate from the Earth to the moon. Secondly, the other list I started building.
Ron,
Yes.
Let me give some immediate feedback to that first one. I'm no expert, but I would propose that we assume that habitats are going to be shielded probably with regolith, and then that's going to adequately address the radiation to some extent, as well as the thermal extremes. So what goes on indoors might be more using cots, maybe with no problem. Maybe with some sort of error checking for the odd GCR that gets through. But then outdoor, my feeling is that we sort of leave the outdoor hardware to people like NASA, and we would just be taking in their data, and we leave it to them to solve the radiation, the thermal changes and radiation issues outdoors.
And certainly that's an approach, and that would clearly limit the scope of where we think we want to put computing devices. So, there's a difference between, putting computing devices inside of a radiation protected habitat or facility versus putting it in a 15-person RV that has the ability to go from a transportation hub out to a nice processing facility over a period of 2 or 3 days.
Yeah.
So again, that's, think of an RV as sort of a roving habitat, but it's clearly going to be different than a well-protected, radiation protected surface or subsurface habitat. So, Eric mentioned, put together some scenarios. So maybe, we can envision and I think this is part of this cislunar concept, is one of my scenario concept is establishing a growth, a sample growth from a very small amount of human gatherings, a scientific outpost, a 5-person ice processing prototype plant, all the way up to a thriving 200-person community with bowling alleys and golf ranges.
All right.
And you don't go from A to C without having a whole lot of A1s, A2s, and B3s and B4s. And so
the moon
again,
goes pretty far. Sorry.
if you swing hard,
So
I think Alan Shepard did.
he did. He did indeed.
So I'm going to take it upon myself before our next meeting to propose what I think is the most realistic scenario for how things are going to develop in the next, probably 10 years. So I'll give that to you guys for consideration.
All right, then quickly, and I will just say, I want to list all the things. The other list that I wrote down was properties of things of our computing devices. Stuff like repairable, recoverable, replaceable, hot backups and restore. I heard several times the concept of high reliability, safety critical, life threatening, adaptable, expandable. I heard we'd like to be able to add stuff on easily or rapidly. Security and privacy. So these are all things, not all of which are going to be probably necessary for every computing device or system. But again, if we develop a day in the life of the town hall, in a lunar community, what do you do in a town hall? You govern and call the police, and you have a 911 or some, sort of for some of us an exotic example, but we have to, that's sort of a good odd one that will make people think about what should human settlements look like on the moon.
One thing that 3Com did when they were developing the Palm Pilot was guys walked around with literal blocks of wood with the user interface just kind of drawn or printed out on it for weeks.
I heard that story.
Just played with it. Right? Rick, do you know this story better than I do?
No, and I don't know if I heard that story from you or from somebody else, but I've heard that story.
It was just the funniest thing. But they were walking around with literal bricks. Nothing to it. But they recorded the ways they wanted to interact with it, and then implemented those as features. So we could totally do something like that as part of our scenario building stuff, even without MDRS or some analog place. It's not that hard to figure out the daily tasks that we're going to be using, smartphones and stuff for. Just kind of if we figure out like a log or something that's common between us that we can exchange that data, but capturing that kind of information might be really, really, really critical or useful rather.
How soon would you all like to meet next?
Oh my, before or after Christmas?
Good point.
I would say after Christmas would be better for me. If we get the vote.
I'm flexible.
Yeah, I'd like to see the email list in the meantime, because I'm sure we'd have some discussion.
Yeah.
On that.
So let's take the first Saturday night after Christmas. Somebody have that calendar in front?
The 28th.
Boy, let's aim for that.
Okay.
It's
December
3
28th.
weeks hence.
And I'm going to hold off on seeing the email list out, and I'm going to reach out to people who indicated that they're probably going to be at this meeting. I'm going to find out if they want to be part of our email list or not.
Okay.
Okay. Thank you, guys. Any thoughts about any last comments about this meeting, this process? I don't know, just your impressions, your feelings.
I'll just go, thanks for the invite. It's super fun, and I can't wait for the next one.
Cool.
It's good.
I think there's a benefit to trying to do everything. Try and build a very simplistic model that's actually going to go to the moon with the actual hardware it's going to go to the moon with, and see if you can get something that essentially does it all, but in a very, very, very simple way.
All right. Okay. Thank you for sharing your time, and we'll work in between. Come up with some of these, this document, Chris. I'll send out the email. Let's feel free to go ahead and communicate that way in the next meeting. Thank you.
Hey, Doug.
Yes.
Are you Fred Becker?
I am not. Oh, maybe.
So I was seeing messages from Fred Becker. Someone was asking me things.
Fred is with the group.
Is he here? Oh,
yeah.
Okay. Because I didn't see his name up here. So
he's just audio. I don't think he has video.
Maybe he's on a, or maybe his name is being covered here. Yeah. So anyway, he was asking me some questions. I don't know if I gave adequate information. That you may need some more documentation, which is one reason for the asking for the email.
I'll go ahead and send out this